那满身阿罗耶。
How to prepare join in RPGSTART programming. Last time we showing the beginning program of RPG has to be running in 32 bits computer. After prepare RPG1, then we can move to 64 bits computer and continue editing the program. Right now we open RPG1.dsw by Visual C++ 6.0 to show on the screen. Since VC++ 6.0 cannot use add file to folder, I can try to show you. Then the program will ask to close the program or not. Whichever you choose, the program will be closed. So we cannot use to add any folder on 64 bits computer. That's the reason why we add code graphic.cpp and the code graphic.h already before moving to 64 bits computer, because today we try to show a way to prepare for dynamic joins on RPG program. Last time we talked already at the beginning of the program. Will run into Vman, and Vman will define app according to the code in this routine. Define the resolution of the screen and the screen style, the window style, and mark something beside the logo, and then continue to run. As long we'll go into code system run and open window, create window and initial count, and then code initial, and then code frame. Traditional, if we run into a routine run and a coding initial, the initial this routine should be exit, then we can code. But as surveying the code system.cpp, it is a class. A class, you can see code system dot header. A class, the class name is CA application, and started from the private, protected, public, and end at here. Last time we say inside the class there are plenty of routines. These are routines, and then divide some variable. Here, divide variables, and we can define a variable inside the program, any routines locally, but there is a big difference between to define the variable inside the class or not. Let's observe first. In here, we define the window's width and the height in the class CAPP application. Watch careful, it's a CAPP application. Well, in the main program, we define a class as well, named CAPP. And here you see the mark here in reference to the public C application. C application is coexistence class. So CAPP just coexistent, and with all the routines and variables can be used inside every routines. So you can see here the CAPP is a class. What class is this class? The Winman's class. Define the object APP. Since CAPP on the top of C application, so inside coexistence, width, height, as the program running into CAPP will call in here CAPP. So the first is here. CAPP's definition. So the width and the height, the variable can be give a value in Winman instead of in here. Here is a class. Class is virtual. The objects is real. So APP is object. The object could give an initial value, the resolution of the screen, and the style of the window. And you see here, the object APP can use all the routines of what? Of coexistence. Can use the variable width, height, and can use all the routines. How to use? Simply app.round. .round to use the routine run. If .move, can use this one. .show mouse can run this one. This is the reason why, as we run the program to this line, the program will debugging inside the coexistence, starting from the first line of run. Open window, create window, show window, update window, resize window, and initial count, and the busy initial routine. It is amazing. Inside the class of CAP application, the initial is a name only, a routine names, nothing inside. If we don't define the inside contents in vmain, in here, the system just busy and left, give nothing, and results nothing at all. Of course, the routine initial, you can give a routines just inside the code system, avoid initial whatever. You can write inside code system, but object-oriented programming, you can give the welcome initial routines and the mother class, and define detailedly a coding program in here. So the program go back to initial and as coding initial, the program debugging will show it will go to CAPP initial, and after return, the program will go back into zero memory next line of code system and running until friend. The friend is a welcome routine as well, as coding friend will jump into the vmain. That's the way the object-oriented programming. So class and object, although it are two things, but it could be seen as one thing. The class is virtual, the object is physical, something like that. How to define the object? Give a class name in front, and at the real give a definition, give a defined name of object, and later on using the object, whenever using the routine of the class, just the object name dot class routine, and running like this. Besides, we give a brief speaking about how to define class, since class is so important. How to define it? We use the main program vmain to show how to define the class. The traditional way to define a class, give it a name class and give it a name. That's it. If reference, give double dot and a referenced class written at the real. It always with area private and with area public traditional too. The private is higher secret, and the public can be used publicly, and end with a quotation, and that's it. You can write variables, open array, written routines. One thing we have to see, the class name CAPP in the public, the first is CAPP, is creator, and then we need a destroyer. We can see in code system. Okay, in code graphics, the class is C graphics with the protected area, with public area, and the end at here. The first line of public is C graphics. This is creator. std code. You can add std code in front. And destroyer give this mark and then the name in here. While in vmain, no destroyer, because we'll close, shut down. We'll close everything already. So you just forget to write the destroyer in here. The code systems with creator as well, no destroyer. The destroyer will close as you run. Will close window. Okay, this is the way the class generating. And speaking again, how to define the object. Define object is at a CPP anywhere, not only CPP. Define a class name in front, CAPP, and give APP a name as object. Let's go back to code graphics. In code graphics, in class definitions of C graphics, you can see, okay, in vmain, in the private, we defined C graphics. C graphics is what? C graphics is code graphics class. Use C graphics define an object. The object name is M graphics. Name inside the vmain, we can use M graphics as objects to define whatever's to prepare the screen for drawing. So the definitions of objects is simple. Use class name in front and give a name and real. This name is look like an object and could be used later on as calling routines of class. Just put a dot in here. Suppose graphic initial, just M graphics dot initial. That's it. Okay, we talked already. It's difficult to use add a folder file to folder, so we prepared code graphics.cpp and code graphics.h already. Then we continue to discuss how to prepare the windows. One thing we have to say, Jim Adams give all the lectures, totally 16 chapters, inside his books CD, and we can run in those chapters using debugging and to see how those codes are working for. Wherever we thought we need this section of the program, we just copy it and duplicate inside RPG1. This way to design a program is fast and accurate as well. And inside RPG1, we still has to debug one line after another to see, to check if there is any error, to correct the error. Okay, go back to prepare the program of join. Then we use CMS CAPP program as the model to copy the files inside the model. We talk already. In VMAN, the initial will initial the graphics. Okay, let's leave RPG1 and enter the program CAPP KH CMS.dsw. Open the program and let's visit initial. In initial, for the starting an RPG program, we have to use graphic initial first. Suppose the resolution of this screen is 1920 cross 1680. We try to solve the problem to display in full screen. So we copy all these programs and press and copy it. Copy these sections into RPG1 and duplicate it in the routine initial. So we push the left button and mark here and choose past. The program will in until here, and then we survey the program. Initial the graphics device and set display modes. The first line use the object m graphics dot initial. And we define use set modes. The resolution 1024/768 and give a variable to check if full screen we run this program and not full screen we run this one. So we have to define a variable pixel adj. We define here pixel adj because this is beginning of the program. We cannot change the value in pixel adj. We just set the pixel adj equivalent to 1 as a constant. So the program will only way to run into these routines, this visit the segment in here. Inside in here, the first line m graphics dot get full screen. You can visit here. M graphics is the class, the object of core graphics. You can see the full screen. The full screen is here. Get the full screen. You have give the window. The header help us to write the program because he will mark in detail how many things has to add in the set modes we written earlier. So we go back to the program. You just put a window. We use GuessWin API of window. It will help us to get a window locally. And then use mgraphic get widths. If you try to see if there is get widths, you can go back to visit here and search get widths. Use mgraphics get widths. The report is dword written inside mwidths. Mwidths is what we just talked in coexistence. We defined mwidths. We just write the getting values in the variable mwidths. And then these slides has no reference. Let's remove it. And then mgraphics get heights, get dwords heights. We write the return values in mheights. The same mheight is defined in coexistence class, application class. And these two lines no use in here. We remove it. And then set mode. The program set mode, this one already. But since we use the variable 1, the program will run to visit here. Then we have new widths 1920, new heights 1680. We have to use set modes to set the new windows. You see so many variables you have to fill in, like the definition of the set mode. In here we just put the variable mwidths and mheight at these two positions. And then code set perspective, the aspect ratios, mwidths divide mheights to get new aspect ratios of the screen. So after this perspective by the new aspect ratio, the model appeared on the screens. We automatically adjust to good shape. It will never change the shape. It will show the model perfectly. If not adjust the full screen, the program just give 4 divided by 3, 1.333 aspect ratios, just like the screen aspect ratio of 1024 by 768. So after this, we have a good aspect ratio and extend to the full screen. If you want to change the width height 1024 and 768 in these two values, it's okay. You can change because in here is the new definition. You don't to worry about what the value these are. Okay, after initial, the program will running back to the fan in code system, and then go back to Vmax code fan. So we have to define the fan, whatever's at the finished, we have to call shutdown. We write the shutdown first before writing the program inside the frame. Okay, we save it and leave RPG1 and go back to our CMS CAPP program to find what inside the shutdown. The shutdown has the graphic initial as finished. You have to shut down the graphics. This is the only things we have to write in shutdown program. Okay, the shutdown program of the CMS CAPP. These lines has server client has no reference with graphic. 232 has no relationship, and the music sound is soundcast, and the buffer nothing to do with graphics, and the virtual buffer in the initial we have no opening of any vertex buffer, so no close needed. The keyboard and the mouse not using these moments. Okay, in here shutdown graphics, use M graphics shutdown. So these two lines we copy it and leave CMS CAPP and go back to RPG1 and feed in two lines copied inside the shutdown and press the left button of the mouse and press past. So as the finished, you have to use mgraphics.shutdown to close the window. Okay, then how about the frame? Frame, we say we have used begin scene and end scene and the display. That's it. That's what we need to copy. Okay, we save RPG. After frame finished, then we can run the program prepared after frame finished. Then we go back to CMS CAPP and find frame. Okay, the frame. The frame is very big of CMS CAPP. We just find begin scene. This is finding the right the characters as much as possible. This will lead the system finding the full strings. Just press enter. Not this one, not this one. Okay, here. Whenever in the frame at the real, you have to display the dynamic join. Then you have call mgraphics begin scene. If it is true, we're running inside programs. The first line you have to call enable Z-buffer. If there are two models, suppose two men appeared on the screen. If not use Z-buffer, then you cannot differentiate which one is in front, which one at the rear, which one cover which one. If you use Z-buffer, then you can see the Z depths on the screen. And this line you need as well, mgraphic clear. Before we display the scene, we have to clean everything on the window size. Use RGB. There are 4 variables, 1, 2, 3, 4 of RGBA definition. So we define RGB. In RGB1, we use the fixed number. That's it, because there's no way to define the RGB as a variable and change the values in the beginning stage. So these 3 lines we copy it. So mark here to here and press right button and copy it and leave the CMS app and re-enter rpg1.dsw and put in frame and past. We say we have to give the fixed value. Suppose the same as this: R 0 pixel, G 0 pixel, B 30 pixel. And then if mgraphics begin scene is true, it will execute mgraphic enable Z buffer return. Before finished, you have to end the scene by return mgraphics. You press dot, you can see how many routines in the class. The system will ask us to choose one. We say we want to end the scene. End the scene in here, right? So put a cursor on it and press the left button of the mouse twice. And since it is a routine, give this one and this one. So like here to here finished. Then we have to give a mark to close it, and then display graphics dot display display here. Press left button twice, and since it is a routine, we have to add something. After display, the program return true. Okay, let's see if let's compile it and run it to see how it works. Save all, build, rebuild all, execute it, and to see if there is 0 error. Okay, the program is ready. Then we can run, build, say debug, go. You can see this is the results. The demonstrations by Dr. Chiao, and then this is the color 00 30, a little blue, light blue in here. If you want to leave the program, just cross here. Now we show if we change RGB, if the R pixel, we give the maximum 255. Totally is 256. From 0 to 255, the maximum is 255. If we give the R 255 and the B is 0, let's see what happened. Let this color to fill the area of the defined screen. Okay, the red, full red 255 is look like this. If we give G 255 full to see what will happen, rebuild all. and run it. It becomes yellow. If we give the B255, what will showing on the screen? That's BO. Zero error. Then we can go by debugging. The RGB all full. The screen will show a white, the really white screens. Then the screen prepared. You can join something on the screen later on.
I see